All right, today we're solving quadratic equations by factoring. Okay, and we're talking about solutions of quadratic equations, okay, which are the points at which the graph intersects the x-axis. Okay, so we call them solutions. Anybody know another name for solutions? Remember, it's crossing the x-axis. What are those called? X-intercepts. Okay, what's another name? Starts with a Z. Zeros. And roots. Maybe that's one you haven't heard before. Okay, so solutions of quadratics and polynomials are x-intercepts, zeros, or roots. So there's have four names. Okay, if it says there's no solution, that means what? It can't be crossing. It can cross the y-axis. It cannot cross the x-axis. Remember, we're talking about the x-axis is when you have a solution, those points. Okay, if there's one solution, it could look like this, where it's just touching. Something like that, maybe. It's meant to be touching. Okay, I'm just making sure. Okay, two solutions could maybe look like this. Okay, so know that that answers to quadratics have no solution, one solution, or two solutions. Would there ever be three solutions?
No.
Why not? It just wouldn't work that way, right? Maybe in a polynomial, which we'll learn about in another unit, but quadratics, no. Okay. Everybody good with that? All right, letter A. What are the solutions for this graph? We're looking for the x value. We're looking for -4 and 0. Okay, we're looking for the x value. We know y is what? Y is going to be what for all of our solutions? 0. Okay, letter B. What is our solution? Okay. Letter C. Andrew, you don't have your folder?
2 and 6.
All right. So now we have another form. What forms have we already learned? We've learned standard form and what else? And vertex form. Okay, so now we're going to learn intercept form. Y equals A, there's our famous A again, times x minus P times x minus Q. Okay? Yes, you'll be foiling. Okay, so that's intercept form. And these are P and Q represent your intercepts. Okay? A represents what? A, but what does that A do?
It's like multiplying.
Okay, when we multiply, what happens to our graph?
It changes the sign of the x. So our
When we think about transformations, what does the A do? Stretch or compression. Okay, so our intercepts are going to stay the same no matter what our stretch or compression would be. Okay. All right, now we're going to factor to find our solutions. Hopefully you factored before. Okay, step 1, set the quadratic equation to 0. Why would we do that? What does that mean? If we have it like this, let's say let's say it's in standard form. Why are we making this 0?
Because you want to find the x-intercept.
When y is?
When y is 0.
Because that's when it's crossing the x-axis. That's why I said y would always be 0. So we equal to 0, and then we factor. Step 3, set each factor equal to 0 and solve for x. Step 4, write your answer in set notation. Okay? And when we factor, the first thing you always look for is your GCF. Okay, if you can GCF to factor, you have to do that first, no matter what. Okay, so let's review factoring by the GCF. Okay, first I'm going to say 0 equals x squared minus 7x. What is my GCF?
G. You could take G.
No, what's my GCF?
1. GCF.
1 will never be a GCF. What do they have in common? What do these two terms have in common? Okay, so I pull out an x, and then I have left over x minus 7 equals 0. Okay, so I have it in intercept form. What are my solutions? Well, don't I just take x equals 0 and x minus 7 equals 0? I take both of these and I equal it to 0. Set each factor equal to 0 and solve for x.
So we would have two solutions for x?
So 7.
7
Okay.
and 0.
7 and 0.
So that's two solutions.
That is two solutions. How could you double check? On your graphing calculator. But if you just do it on your graphing calculator and you don't show your work, will I give you full credit?
No.
No.
Well, what do
Why
we
is
do?
it not negative 7?
Because you're solving for x. If I do plus 7 on the other side, you have to do plus 7, x equals 7. Yeah.
Wait, how would you check it in your calculator? Would you graph it?
You can graph the original function, see where it crosses the x-axis.
Oh, okay.
Just like we saw the graphs up there, right? Okay, letter B, what's my GCF?
3?
What is it?
Is it
3, is that it?
3?
X. So what's left over is x minus 4 equals 0.
What would you do with this? Oh, well,
It would be like negative 3.
You put 3x equal to 0. What's that going to equal? X is going to equal,
Whatever.
I'm sorry?
0.
It would equal 0. 0 divided by 3 is 0. And then you have x minus 4 equals 0. So what does x equal? 4. So we have 0 and 4. All right, next page. Now we're going to learn the basic method. So we did GCF. Now we're doing the basic method. Okay, and that is you take the factors of C. Factors means they're being multiplied. That add up to B. All right, so factors of C have to add up to B. Step 1, factor out the GCF if there is one. Okay, and it's important that we have a positive A. Step 2, find the factors of C that add up to B. Okay, so in this one, again, we're going to say negative x squared minus x plus 42 equals 0, right? That's our first thing we always have to do. Now, I have to have a positive A. Do I have a positive A? No, it's negative. So in this case, I'm not factoring out 1, I'm factoring out negative 1.
Would it be can have -1?
Okay, so we factored out our negative 1. Now I'm going to factor this middle part. Okay, what factors of 42, when added together, will give me 1? So it's negative 42. What factors of negative 42 add up together?
42.
Okay, which one's negative, which one's positive? Very good.
Oh, yeah, I remember this.
So my solutions, I can ignore this negative 1 because it doesn't have an x with it. What's my solution? Negative 7 and positive 6, remember? Because you take the x plus and solve for x. So in a way, it's the opposite of what's in the binomial. All right, letter B. Okay, we have 2x squared plus 20x plus 50 equals 0. What's my GCF? 2. So I have left over x squared plus 10x plus 25 equals 0. What are my two factors that 5 and 5? X plus 5 and x plus 5 equals 0. So what are my solutions? So just negative 5. Okay, that's one of those where it just touches there, right? Because it's only crossing the x-axis once. Slip and divide or slip and slide, maybe it's been called. Oh, good. All right, step 1, factor out the GCF if there is one. You can see a theme here. You're always looking for that GCF if there is one. Step 2, multiply A and C for a new C term. Step 3, factor the trinomial using the basic method. Step 4, divide the last by A and simplify. Step 5, denominators are your first and numerators are your last. Okay, so those are the steps in case you forget, but we're going to do it together now. Is there a GCF? No. So I'll put 3x squared minus 14x minus 5 equals 0. Okay, I have no GCF, so I'm going to go to step 2. Multiply A and C for a new C term. So I'm slipping this guy down here by multiplying him. So I'm going to have an x squared minus 14x minus 15 equals 0. So that's the slip part. I'm slipping the 3 down to the 5. Now I can use the basic method to factor. And what would I get?
15 and negative
Okay, so negative 15 and positive 1. Am I done? No, what's my next step? Divide the last by a. Okay, whatever my a term was, I need to divide it back out, right? I slipped it and now I'm dividing it. My a term. If I can simplify, I should. 15 divided by 3 is 5. So now I have the term x minus 5. Can I simplify anything here? So what does it say we should do? We have a fraction here. What should I do? The denominator is your first, so I'll have 3x, and this numerator is my last. All right, so we left it as 5. Okay, so my answer is 5 and negative 1/3. Okay, if you took that 3x plus 1 equals 0, you would get x equals negative 1/3. All right, letter D. Do we have a GCF? What is it? Okay, so I have 3 times 10 x squared minus 9x plus 2 equals 0. Okay, now I'm going to have to do what? So I have x squared minus 9x plus 20. I slipped that 10 down because I don't like him. Okay, I want to be able to factor simply. Okay, now I need to factor. So what do I get?
-4 and -5.
X minus 4 and x minus 5. Oops, minus 5. I say 5 and I write 4. Okay. Now what do I do? Divide by 10. Okay, so I can simplify over here. They both, 2 can go into both.
So it's 5.
This one is 1 and this one is 5.
So would it be 5x?
So I have 5x minus 2 times.
Yes.
Oh, wait, I'm dividing by 5. This should be a 2. Right? 5 divided by 5 is 1. 10 divided by 5 is 2. So I should have 2x minus 1. And what are my two solutions?
2 over 5 and 1 over 2.
Very good. Okay, we're going to learn one more method. Okay, we will see these methods again when we do polynomials. That's why we do quadratics first, and then when we get to polynomials, you already have these methods down because we add like 3 more methods. So these will not go away. This is not something we should forget about. All right, difference of 2 squares. Take the square root of both a and c. Okay, step 1, factor out the GCF if there is one. Step 2, square root a and c. Step 3, use the roots to create your factors. All right, do we have a GCF? No, so we're going to say x squared minus 16 equals 0. And then it says to square root a and square root c. Oops. Okay, let me see that. Okay, what's the square root of x squared? X. And what's the square root of 16?
4.
Okay, so essentially the difference of squares is going to be x plus, let's just say a times x minus a, if you want to say it like that. Same, should be the same number. Okay, it's plus or minus. Okay, so this is when you have 2 terms. You should be thinking of this method. 2 terms. All right, letter F, GCF. Is there one? No, there is not. So I'm going to say 4x squared minus 81 equals 0. Teo, what should I do? Square root. Okay. And what's the square root of 4x squared? 2x. So I have a 2x here and a 2x here. Yes, plus 9, because I do the square root of 1 is 9, and then minus 9. It has to be plus and a minus.
Then negative 9
I think Mariano could have taught the whole lesson. Okay, we would have negative 9 halves, positive 9 halves.